This is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 Nightcrawler presents this weekly FRC gathering where FIRST robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
Okay, I've started the recording. So I think I heard somebody join, a couple of people join while I was out of the room starting the recording. Tonight's topic is OnShape, and we are going to, Isaac Johnson from Nightcrawler has volunteered to give a lesson tonight. It's sort of the first lesson we give students on Nightcrawler when we start teaching them how to do CAD for robotics. And then, Isaac, are you okay with people just interrupting and asking questions as you go?
Oh, yeah, go ahead. Breaks it up a bit.
Okay. Why don't you see if you can share your screen and make sure we can all see it?
All
right.
Is that good?
Yep, we can see it. Okay.
So
Isaac, I'm going to let you take over from here. And the floor is yours. Feel free. I mean, if you have any questions, you can say, "Wait, how did you do that?" Or can you go back and do that again? Go ahead, ask Isaac. He's prepared to be interrupted.
Yep. Okay. So I have a document that I just made and renamed. And first thing I'm gonna do is make a variable studio, just to easily change the length and width of our robot chassis after it's made. Actually, first thing I'm going to do is change it to inches. So I'm just going to do 30 by 30 to start off with. And going to make a 2 by 1 just for the frame before anything. And I'm pretty sure we use 16th inch, so I'm going to do that. Going to make an extrusion of it, so using the variable we set up. Going to make another for if we have had different lengths. And then, so we use a inserter called MKCAD during the season. So this will just, if we search up Swerve, we can just insert the modules. But it's currently not working, so I'm just gonna use the normal inserting method.
Isaac, can you go to the website that shows everybody how to install the MKCAD tool?
Yeah. Do you have the link?
It's OnShape, the number 4, FRC.com. So Isaac noticed on Friday that something's going on with OnShape and MKCAD, and the insert doesn't actually work now, and I'm sure it's a recent bug with some OnShape update that they'll get fixed. But this MKCAD library has a ton of AndyMark and Vex and Rev and all kinds of cool stuff that it'll automatically link to a public parts document and allow you to import that right into whatever document you're working on. So Isaac's going to do it the manual way here because something's going on with his MKCAD plugin. But you can go out and find these sort of modules that someone else has designed or someone else has imported, and unless you're on a paid OnShape account, all of your documents are public. So you can go out and just find somebody else's model that they imported, or maybe they just drew from scratch. That's unlikely they would do that for Swerve, but they might do that for something else like a PCM outline or something like that you want to incorporate. But you can import a part or an assembly directly into your document. The nice thing about this MKCAD thing is that it was a nice searchable index and it would automatically do this search and import for you. But, you can also do it manually if things don't quite work the right way. So what Isaac just did there is he went out and searched and found somebody who had who had imported either the step file, probably step file. They imported the step file into their own document, and so he's just borrowing their part. The downside of that is if they end up deleting their document, then the link to what they're using goes away. That's why using the MKCAD library is a little bit more reliable because those are sort of the official drawings. Sorry, go ahead, Isaac. You can continue narrating.
Yep. So what I just did there is I'm going and we use the Mark IV-I with Neos. And so I'm just going and taking the distance I need to remove off of the metal that you would cut so that we can use these holes. So that we just mount everything correctly. And it looks like 4.5 inches, but I'm gonna add 1/2 inch back so that it isn't just half a hole. And I'm also going to use the measuring tool again just to check the distance between these. I'm using the center one so that when I go and use or put in the holes for here, all I have to do is just make a sketch.
Can you separate those two parts, Isaac? Or is there a reason why you want them together?
Yeah, I can separate them, but they're off of the same sketch.
Oh, I see.
Yeah.
Oh, you can just reverse it. I get it. That's nice.
So I'm going to go back into my sketch and just make the holes real quick. Actually, I'm going to make a variable here so that don't have to type in 0.25 every time. Just put 0.25 as the variable. Then.
But wait, isn't that distance a 1/2 inch? I thought that was, you were saying that you're going to be a 1/2 inch from the end. Or is that not right?
Yeah. Okay, so the distance from here to here is, where is it? 4.5 inches, but that's from the edge to the center. So I'm just adding 1/2 inch to be safe so that we don't have a piece that would just so the hole doesn't get cut out.
Mm-hmm.
Actually, that's right. And then I'm just going to select all these and make them parallel. Oh, that's an arc. Make all these parallel so that they're in line. And gonna make all of these holes equal, and the spacing 1 inch, so that we can actually use the holes, or use the bolts that we measured. I'm gonna do the same on the other end. Now I'm gonna mirror both of these so that both of our pieces are, or have the holes. Oops. Mirror. Yep. Then I'm gonna hit extrude and switch it to remove and merge with all so that it removes holes through all of the metal. Then I'm gonna insert this in roughly the same way that I did for the swerve module themselves. And then I'm gonna use the fasten mate up here to fasten the top of this to that hole. Then just do the same here for all of these modules. Give me a second. That's the wrong hole. There we go. Now just gonna double check that it's the right length.
$34.5. Is that what you wanted?
No. Got to take off. What was it?
3.7.
The whole thing. Yeah.
Oh, okay.
Because I only compensated for the one swerve module, which good to check. So now going in to here, 30 inches. So I can continue to do that all the way around.
So as Isaac is doing this, one of the things that I found tricky when I was first starting on this CAD was especially mates. Doing mates in the assembly, it takes a kind of a special spatial brain pattern, which you can see Isaac has done a good job of developing here. But you can also take these parts and just kind of slide them around and rotate them around the model and get them close. And that can also make it easy to get the mates that you want lined up properly. So in this case, he's taking the circular part of the hole and he's identifying the face that's going to touch the other face's circular part of the bolt. And that's how he's sort of attaching them together. So mates are basically attachment points. So if you're new to OnShape and you're trying to understand how do you attach things together, see right there, he's finding the circle for the top of the extrusion, the 1x2, and then the circle in the bottom of the plate for the swerve module. And he's saying that these two things are going to stick together. And there you go. We made a swerve chassis frame.
Yep. Should I do the bumpers as well?
10 minutes. Yeah, so Isaac's done a good job of showing how you would take basically MKCAD parts or stock parts and be able to kind of glue them all together. And that's really great. In fact, when I started learning CAD, I was going through the OnShape tutorials, and it was basically how would you build solid shapes from scratch. And I thought to myself, how in the world am I ever going to design a robot? And then I started watching tutorials on how to do FRC OnShape, and it's like, oh, you just go get all these pre-built modules that someone else has put together, and all you have to do is kind of stitch them together. And then the only thing you sort of have to make from scratch is your plates that you would cut on a CNC or the box extrusion that you would cut. One of the things you can do too that's a little bit of a shortcut instead of making your own box is, Isaac, can you open up the MKCAD and go to and search for VersaFrame? So you can get VersaFrame in here, and when you pick this, like you pick that aluminum VersaFrame, it asks you how big of a VersaFrame do you want, how many inches do you want it, how many. It knows that it's going to put all holes in at 1-inch holes, and then it asks you how far in do you want your first hole. So again, if MKCAD was working, and once they get their bug fixed, I'm sure it will be working again. The nice thing about that Versa chassis is it's really easy to make extrusion. In fact, if you go, another thing is if you go back to that OnShape for FRC website, Isaac, there's lots of plugins in here. And this is a really great website, but there's lots of plugins in here for making extrusion. You can make churros, you can make hex shaft. It has a kind of a built-in Swiss cheeser, custom length extrusion, shaft generator. There's a whole bunch of things in here that are really nice thing. Gusset. So you have a couple of pieces of aluminum and you need a special gusset. It'll create a gusset for you. Lightener there. So the lightener will do kind of Swiss cheesing for you. Plate generator. There's all kinds of great plugins for OnShape in this OnShape for FRC website, and it's definitely worthwhile in taking a look at some of the things that are in here. We've only used a few of the different tools that are in here, but it's a really neat place to get some really nice plugins. Okay, sorry, I interrupted.
Yep. I'll save one of those for later. But so now, something cool that we did since I used the variables for all this is I can make it more accurate to our actual robot. And
Missed a mate.
Yep.
Oh, and you lost a hole. Well, that's probably why you missed the mates, because you lost your extrusion holes in the end of your side pieces. Weird. Probably because of the mirror.
Oh, yeah.
Oh, okay. Yeah, you got to move. Yeah, okay.
I'm just gonna set this back since wasn't thinking about that.
Okay. Yeah. You were trying to do it as fast as possible.
Yep. Okay, so now gonna make FRC legal bumpers. So gotta be 3-inch. Then a neat way to actually do this is to make circles. So just make 1.5 inch, 1.5 inch. Then
No, wait, no, bumpers are 2.5 inches.
2.5 inches. Oh, okay then. Wait, is it 2.5 outwards?
It's a 7-inch plywood,
7-inch plywood. Okay.
right? Isn't that, somebody help me out here. Now I'm gonna have to look it up. It must be 5-inch plywood because that wouldn't only make sense if your pool noodles look 2.5.
Yeah, well, whatever it is. So just
Gosh, you take 2 weeks off of FRC and then you fail. You forget everything.
gonna make circles and use tangent mates. And this is gonna make it so that they're constrained. And then we can just add the front here.
And then you gotta add your 3/4 inch plywood in the back too. Don't forget that.
Oh, yeah. Point. Yep. Oh, I delayed it somehow. Anything to say just to fill time?
Sure. So one of the things that you can do here to fake out bumpers and what Isaac's doing here is he's just getting the rough dimensions and he's basically pretending or assuming that it's just going to be one solid piece of material. We don't actually need to have our bumpers constructed with foam and plywood and stuff. In this case, all he's doing is he's just making the shape so that when we are looking at a robot and we're bumping the robot up against the, like, for example, in our case, the side loading feeder station, we want to know how far away from the side loading feeder station our frame's going to be, and therefore how far away our intake mechanism is going to be. So that's why we're just getting the bumpers to basically look like just a solid chunk of rubber or wood or just material rather than made up of all the parts. Okay, so you got a bumper and you're doing a length plus.
Yeah.
No, it's going to be 7 because it's
7?
2.5 plus 2.5 plus 3/4 plus 3/4. So 6.5, right?
Yes.
So length plus 6.5. There you go.
Just gotta remember your units.
Yeah. And then you'll need another one that's the width 6.5. Assuming that you're going to 45 them, right?
Yep.
And again, we don't 45 our bumpers on Nightcrawler in the corners like that, but for the sake of the model, it makes the model look nice and clean if we just make our bumpers one big rectangle. .5 plus 7.5. Yep. So 3.25. There you go.
Draw. So just cutting the corners and now can put 4 of them into our assembly. And since it's the same dimension, you can just use the same one.
So in this case, Isaac's mating on the center of the back of the bumper to the center of the frame. And then you want to show everybody how you would raise it up.
Yep. So if we want to raise it up so that, say it's, hold on, so that it is like a bit off the ground, you just hit the offset button right here in the little dialog that pops up and offset it in the Y direction, since that's the one that's facing upwards. Whatever you want to do, like 2/4 inch or maybe even
I would
an
say,
inch.
yeah, raise it up an inch. That looks a lot better.
And then you can just double click on a fasten to change it, hit offset, then. Another way of like putting or mating these together, if you've already got one on, is just to mate them like to each other using the center of the edge.
That's true, because then you could just raise and lower it by changing one adjustment, and all the rest of them will just move up with it.
Sometimes the mate will look something like this, and all you got to do is rotate it and flip it until it's working correctly.
Yeah, and one thing you didn't, something about that, when you were putting your MK modules, you were doing the rotate, but one thing OnShape doesn't do is when he was rotating the entire swerve module, it was only rotating that one plate. And then if you hit that solve button, then it'll move the entire, all the other parts that are attached to it around as well, so you can see what it'll look like before you complete your mate. So that's what that solve button is for, is that when you do the rotation, it may only rotate part of the thing you're trying to rotate. And if you hit the solve button, it'll redraw everything to match up with the one part it rotated. It'll move all the other parts to line up with it.
Okay.
There you go.
There we go.
Completed chassis. So that was really quick, and the goal here was less about trying to teach everyone how to use CAD, but to show you how quick it can be to do things in CAD once you've taken the time to learn some of this stuff. So I will offer this. I would recommend that everybody go through the first maybe 4 or 5 lessons in the OnShape training. The OnShape's online training, official training, is really, really good, and it teaches you how to use the mice, what left click does, what right click does, how the drags all work. It's really simple and intuitive. I spent a couple of years doing SolidWorks, and then when COVID hit and we had to start doing things online, the team switched over to OnShape, and I found going from SolidWorks to OnShape, it only took a minute for me to kind of, the controls are a little bit different, but they just seem so much more intuitive to me. And then when I had to go back to OnShape and go back to SolidWorks and do some things in SolidWorks, I started getting kind of frustrated with some of the things that weren't as convenient to do. So I found that OnShape was a lot easier to learn than SolidWorks was. So if you go through those first few lessons and you just sort of understand the basics of mouse control, and then you start learning how you can go find common off-the-shelf robot parts like your compliant wheels and your Falcon motors and your Neo motors and all of those things, and you can just start bringing them into your assembly. Things get so quick. It's really surprising how fast just this lesson that Isaac did. We gave this lesson to all of our build students who wanted to learn CAD, and we would basically have them do it, and Isaac or myself or eventually some of the other students would sit behind them and say, okay, now click on this, now click on that, okay, now draw this over here. And we would step by step walk them through making this chassis. And that was their first experience with OnShape, is we would sit behind them and we would have them make this exact same thing that Isaac just made. And we would tell them step by step what to do. And it was surprising how that 1 hour long backseat driving kind of lesson that's all it took for a lot of our kids to say, okay, I get the basics. Now the rest of the stuff, I'm going to try to figure it out on my own. And of course, they would come and they would ask questions. But this one lesson here did some really important things. It taught them how to go find a part and import it into their assembly, which is what we did with the Sword modules. It taught them how to build sort of common off-the-shelf type parts like the extrusion from scratch, and how to use variables to do that so they can change the lengths very quickly. And then how to build more complicated shapes that they would extrude. And in this case, that was the bumpers, where it's not super complicated. It's a couple of rectangles and some circles, but it's still starting with a sketch and then extruding it out and then clipping the corners at a 45-degree angle. And what we found was if we had the students do just that much, it was enough of an intro, and it gave them the confidence to say, wow, that looks awesome. And it looks complicated, but it turns out it wasn't that hard. Then they were able to start building other things building an elevator, going out and finding the Andy Mark parts, the step files, and importing those. Hey, Isaac, can we do that? Can we show how to bring in an external drawing into your drawing? So can we just go out to Andy Mark and find like bearing blocks or something, or compliant wheels or something, and just bring that step file in and show how the import process works?
Yep. How about star wheels?
It's sort of an inside joke with the Nightcrawler because we bought a lot of star wheels thinking we were going to need them for the robots. Anybody need star wheels? We've got lots to share. So you need to find the step file and download that to your computer, which Isaac has done here. I see an AM0619 step file was downloaded. So then you go to the plus sign, you say import, and then you want to import it into, make it a part. Yep. So it's good to import it as an individual part, because then you can kind of mess with it as an individual part if you want to. So he picked his file, and now he's got a part for the star wheel in his document. So and then he can go into his assembly, and he can say, I want to insert a part. And there you go. He just imported a star wheel. So it gets really simple, because everything you buy for robotics, almost everything you buy for robotics, has got a step file on the site. So every place that we buy parts, and I'm sure everyone else is very similar stuff, you can almost find a step file just about anything that we buy that's COTS. And then you can just take that step file, load it up into OnShape as a part, and now you've got that part and you can do everything you want to do with it. There's another thing that I wanted to cover tonight, Isaac, and you did it really, really fast where you're looking at dimensions, but I'm wondering if you could go into the Nightcrawler folder and bring up the field file and show people how we would check the dimensions of the field in the quote unquote old days when we were taping out our field on the carpet, or we were designing a mechanism. We'd have to say, how high is that off the floor? We would have to pour through the manual, and then maybe it would be in the manual, and then you'd go to the field setup PDF that the FTAs use to figure out how to mark out their field. We would go through all of that stuff and try to find the dimension. And now all we do is we just go find the official field drawing, and we made a copy of the field and brought it right into the Nightcrawler CAD space. So it's a big drawing. It takes a bit to load. But once you get it all loaded, you have the entire field layout available in CAD. And I think Isaac's computer is stuttering a little bit, because not only is he worth looking at a gigantic document, but he's also broadcasting over the web. But if you want to measure the distance between two things, so let's take, for example, how far is it from the grid to the charge station? This is a common thing that our autonomous folks are always looking at, is how far is it from the grid to the charge station? So there he's going to select on the face of just one of the elements on the grid, and then he's going to select the line on the front of the charge station. And then can you pull up the little tape measure over here? So it gives you all kinds of distances. And if you hover over them, so there's that red line, and see, you got highlighted. So 60 and 5/8. is how far it is. And then the green line, what's the green line to? That is that's a left and right line.
Yeah.
So the green line it's just a left and right from where he clicked in the two spots. So you can sort of ignore that. All we really care about is that 60 and 5/8 inches there on the X. So this makes it really easy, even if you don't have any skill in CAD at all, and you're like, mates are too hard, I can't get my brain around it, I'm just not a spatial person. This type of thing is really, really good skill to have everyone on the team know, because even if you're a programmer and you don't have to have any business at all designing the robot, being able to go in and look at the field drawing or something else. Maybe you need to know how big is the elevator going to be, and you need to kind of guess. You've got some gear ratio figured out for how many rotations of the motor drive an inch of the chain to raise the elevator. You can go into the CAD and click on two things and see how far apart they are. So this is a really good skill for all students and all mentors to have if you're doing anything with the robot, even if it's programming, to be able to tell how something is. So that looks like that's the height of the top of the pipe from the carpet, from the tape. So it's, which one is it? It's the Z. So it's 40, 45 and looks like 15 sixteenths maybe up, and 39, basically 39 back, 39 to 32nd maybe back from the tape. So these are really good kind of CAD skills to have, even if you don't plan to do any designing, just to be able to get in here and navigate around the document. If you get something selected that's the wrong thing, you can either click on it again to get rid of it, or you can click on the white space that's not part of the document, and that'll clear the selection. There's probably a shortcut key to clear it too.
Also, if like you just can't find a place to click off, you can right click and hit where is it? Clear selection here.
There you go. Yep. Sometimes you get zoomed into just the perfect thing, and then you accidentally click the entire carpet. And so you can go in and you can just, without having to zoom all the way out, you can do what Isaac said of clear the whole selection. Well, that's another good one, is how far is that reflective tape off the floor? So these are great things to be able to do in the CAD, is just to be able to figure out the distances between things. Any other tips that you want to kind of share tonight, Isaac, with CAD?
Like introductory level?
Well, just in general. I mean, you and I talked about how to design a 4-bar mechanism, but I think that's a much bigger topic for a later time.
Mm. Yeah.
So Ben asks, how do you make sure everyone on the team can access this? Okay, so Isaac, can you kind of give it a description of the team folder? So first of all, FRC Teams get some type of a team account. If you search OnShape FRC discount or something like that, you can contact OnShape and say, we're an FRC team, we'd like a team space, and they will give you, I think, a free team space. So there you go, how to onboard and that's an OnShape site. So OnShape's totally on board with helping out FRC teams. If you go in here, you'll get some type of I don't know if it's a nonprofit type of discount or something like that. But you can set up a team space in OnShape, and then you can invite your members of your team to be part of the shared space. And then you can, everybody can work on the same documents. Everybody can see the same documents. Isaac, can we take a look at our robot from this year and kind of share how we let people play around with the robot document without actually destroying the good design, the quote unquote good design?
Yeah, of course. So we have our main robot here with like block just to measure from the floor, like grids. But so if you want to make a copy of it so that you can modify it without like destroying the design, like if I wanted to just remove this arm here and redesign it, all you have to do is just hit this little 3 bars and go to copy workspace. Then you can just make copy, name it copy Isaac 19.
Yeah, we recommend that if students are making copies of the official robot diagram, then we ask them to make a copy with their name on it, and then they can play around with it, make some changes, suggest some different parts and mechanisms, and then we'll know whose copy is whose, and we don't have to worry about it. OnShape actually does have version control, and you can sort of mark a version, name a version. You can branch. It's if you're familiar with programming, it has a Git-like structure to it. But what we found is that it's not nearly as convenient to say, oh, I want to check out this branch, or I want to check out that branch. We found that that's a little bit cumbersome, and it's easier for people to just have their own documents. And then, and there you can see the version history. So new bumpers, Scott done something before I started messing around with stuff. So I always would make a version before I go in here and mess with Isaac's drawing, so that I could at least go back to that version and say, yep, that's not okay. And then if someone does make a copy and they have a part and it's like, oh yeah, this is going to be awesome, what you can do is you can right click on the part in the bottom, and you can say, move this to a different document. And then you could move that back to the kind of official document. So that gives you a great way to sort of have your own version of the robot to play around with all you want. And then if you end up building the perfect elevator or the perfect bracket or whatever it is you want, then you can actually move that part back to an entirely different document. And in this case, you'd move it from your playground document, and you could move it back to the official document. Now, if you're an engineer on the call, you're probably cringing with horror that that's actually how you would do document management, because it does sound icky and awful. But for students that are just getting started with CAD, we found that it's probably the safest way to handle that type of situation.
Should we go into how, like, you can make, like, a folder and, like, just organize stuff within a drive that you create for the team?
Well, I'm curious. Isaac and I have been doing a lot of talking here. This wasn't really intended to be so much a lecture. Who's got questions? What do you guys want to see? By the way, Ian, you're right. 3D printing wheels out of TPU. We actually did print some wheels out of TPU. It's a good option if you have a good enough 3D printer that could do a good TPU laydown.
Yeah. So, Roger, with your question about if we drew the field, so we just found it on we found it. You can find it on First, or if you just search there's a public tab here, and you can see what people are doing. Like, there's an engine, but if you just search FRC 2023 field, then you'll get
tons of people have copied, just like us. We copied the field into our workspace. There's tons and tons of copies of the field.
Yep.
I don't know how to find the official one though. There may not be an official one on the FRC. Someone probably did the big import from the SolidWorks file or the step file, and then everybody's just been copying from it. Ben wants to see our process for 4-bar linkage. We could have a discussion of it, but it's a big topic. And in fact, there's so many different ways to design a 4-bar and even a 6-bar linkage. We have not learned how to do a 6-bar linkage yet. We'd love for somebody to teach us. But when we were trying to figure out how to make a 4-bar linkage, we were scouring the internet. We were scouring the internet for training and tutorials on how to do a 4-bar linkage. And we found 3 different methods. We liked 2 of them. And so we kind of bounced back and forth between the 2 different ways to make 4-bar linkages with our design. I guess we could get into that. But before we go into 4-bar linkages, because again, I think this could be an entire design meeting. Does anyone else have any other questions? Someday. Ben said someday.
Rotating in slider mates, working with
others? Let's talk about slider mates, because slider mates are kind of tricky, and you could you could make a copy of you could take your copy of the robot you just made and throw away all your mates on our elevator and then redo the mates on the elevator. That might be a great lesson.
Okay. Yeah, I'm just going to throw them all away on the main elevator because don't want to go through all the tabs.
Okay, so now if you drag those things around, see they'll go anywhere. Yep. So we've lost our constraints. We've lost our sliders. Oh, you lost the mates on your... Oh, you lost all your mates. Okay, I get it. So anyway, so let's do some mates. This will be a good wrap up to our CAD lesson.
Okay,
because
so
by the time you get all these mates put back together, it'll probably be 8 o'clock.
Yep. Okay, so taking the slider mate from up here with all the rest of them, then you just take the face of one of them and the face of the other, and then hit solve, and it will slide in the direction or in the axis. Or okay, if you see that I have the like face of here, it's up and down a Z, and the face of here up and down a Z, it'll go on the Z axis. And if I set like this face here with this face here, it'll go up and down from the face that you do it.
Boy, that's really hard to see.
Yeah.
But the point is that it's easiest if you put your mates in the line that you want them to travel, right? That's what you're trying to demonstrate? Yeah. So in this case, the bottom face of the elevators made it really easy to get them to slide in the right orientation you wanted. Now you have to constrain them.
Yeah. Let's see. So sliders, you can limit them so that they can only go so far down. So I'm just going to go into the mate, then just click limit, and I can say the minimum distance 0. So that, or wait, yeah, the minimum distance is 0. So the lowest it can go it's inverted.
You got it. Yeah. So the next one, that'll have to be negative. So that means your minimum will be, your maximum will be 0 and your minimum will be like negative. Yeah, I don't remember how big our elevator is. Is it 48? Oh, that's pretty good. Yeah. So we probably would never want our elevator to go any higher than 30 inches. And in fact, we have it at 0, but we probably would never want it to bottom out. We'd probably want it to stop an inch before the bottom.
Yeah.
Because you just destroyed your bearings.
Yep. So now this one should go the same distance. I would suggest playing around with it and figuring out how to not have it or not have to invert it every time. I should probably do as well.
Slider mates are kind of tricky. Revolute mates are kind of tricky too. I see that you had a shaft up there for on the pulley. We can show how revolute mate works with that hex shaft that you have.
Yeah, okay. Or I'm gonna do it with the bearing
yeah,
here.
Do it with the
That'll
bearing.
work better. So a revolute mate. If we take it here, so you click the edge that you want it to. So at first it acts, or at least with circular objects, it acts like a fasten mate, where you click the edge you want it to go and put it to the edge that you want it to be up against. But depending on how you put it on, since here it's 2 circles to each other, let me fix that real quick. It'll want to rotate because I can't think of how to explain it off the top of my head, Scott.
I'm not sure what you're saying though. Because you've got you put the revolute mate circle in a circle, so I mean it's doing what you want to do. It, like you said, it sort of acts like a fasten mate, and then it tries to figure out. OnShape's pretty good about figuring out, saying, okay, I made it in this circle, and then it figures out, oh, well, I'm spinning in this rotation in this circle, so that's working just fine.
If you do it without a circle, it won't spin the circle. It'll instead spin in the spin along the edge that you did it. So if I take this edge and this edge, it's going to put them together like a fasten mate. Except since I did the edges together, it's going to rotate around the edge, kind of like it's hinged.
Got it.
So
and that makes sense, right? OnShape's kind of smart about that, saying, well, obviously what you're trying to do here is do a hinge. So OnShape's pretty smart. If it's not doing what you think it should do, it's probably because you've given it bad instructions. And sometimes you just have to play with it, and then you'll figure out, oh, I get it. Now I see what it's trying to do. A good question. The different mates, I mean, I think that separates beginners from intermediate people is once they start understanding the mates and they understand how to fasten things together, especially when you're talking about allowing movement. Isaac, can you go back to our official robot drawing and then show the movement that's in our, we don't want to talk about how we built the 4-bar, but you can show the movement that's in our 4-bar mechanism and how the pistons are part of that. You can see the pistons will go in and out. So, I mean, it's just, we could not have built this thing without CAD. There's just no way that Nightcrawler would have been able to build the mechanism that we built this year without CAD. We've done some 4-bars in the past. Nothing has ever had this level of precision in the geometry. And part of that was because we had to have 3 very specific positions for this mechanism. If you go back to the full robot, Isaac. So right here. So let's go all the way down to the ground and we can show how we pick up off the ground with this mechanism. So this 4-bar had to, when fully extended, and it's a piston, so it's only got 2 positions. So when fully extended, it had to be right on the ground to do ground pickup. You can see that the part of one of the 4 bars is actually a brace that sits on the bumper. So that creates a support so that it would sit right on the bumper when on the ground. And then that's how we would do our mechanism. Now, if you go up to the top pole and show how we do drop off. So slide the elevator up. Oh, you've got pre-positions. So there, it's fully raised up. The cube's at sort of like a 30-degree angle, and we spit it out, and it pops right on the pipe. And so it had to be the right distance away from the elevator so that when your bumpers are right up against the grid, you run up to the grid, and it would spit it right out. And then the final one is what we call baby bird. Oh, there you got a cone. So there you go. Put a cone in the mechanism, and it spits it right out. And then from the single substation, if we are down almost to the bottom, but not quite, and we're in the retracted position, we had to build this thing so that when it's in its retracted position, you could load from the single substation and it would slide down the chute and it would fall right into the open mouth, which is why we call it baby bird, right into our mechanism. So because we use pneumatics, we only had 2 positions. We had retracted and extended, but we had to accomplish these very specific objectives with very tight dimensions in all the places. And if it wouldn't have been for OnShape, I just don't think there's any way we would have figured out how to make this work this year. So Isaac worked gazillions of hours on this on his own time to work on these mechanisms between meetings. And because of that, we're very pleased with our intake, and now we feel very comfortable with the CAD skill that we have on our team. And Isaac's done a great job of helping other students learn how to do CAD. And we're excited that we're going to have more students in OnShape next year. Half our build team, I think, at this point is can get into OnShape and start building gussets and putting together, off-the-shelf parts, COTS, into an assembly. Jesse, you guys also use Baby Bird. That's great. Yeah, it's a great name.
First thing we thought of. Yeah.
Yeah, you just drive over there and open up, get fed. Any other questions? We're getting close to 8 o'clock. This is the timing is really good because I was hoping that we would wrap up sort of our demos at 8 and then sort of have discussion about other CAD. Anyone else using OnShape or using SolidWorks and want to share kind of their process for training or their success that they had in CAD this year, or maybe, struggles that you had and want to share that? Nobody? Everybody's worn out this year. Robotics is over. What are we doing?
Do you got a list of some tutorial videos that you guys had went through as you were learning the process of OnShape? Have you created some that you'd be willing to share?
We haven't created any yet, and that's one of our summer tasks, although we haven't officially assigned our summer task, but that's on my list of we need to make OnShape training videos. But Isaac, stop sharing. I'm going to share, and I'm going to see if I can find the official videos. Share the screen. So in 2020, when our team OnShape training. In 2020, when our team decided we were going to learn OnShape, I started here. So I started at the official on self-paced courses, CAD basics. These are actually pretty good. And I know that in 2020, our team, all the students on their build team did this model. I assume they did because I saw them all show up in our team account. But these videos are actually really, really well done. I went through several of these videos when I was learning how to do OnShape, and they're really well done videos. But what this doesn't do, and what the big thing I was missing is that, okay, fine, I can make this stuff from scratch. I can create something that I could 3D print, but that doesn't help me design a robot. And it wasn't until I went out on YouTube and I started watching videos on how to use OnShape for FRC specific stuff that I saw people importing step files, or that's how I learned about the MKCAD. And so, intro to OnShape for FRC. So there's some really great videos out here. OnShape FRC robot organization. So this can be really good too. Spectrum does a great job. There's Citrus Circuits. I wouldn't hesitate one bit to spend hours on YouTube just searching for FRC OnShape and finding all these great videos of how to do things. When we were learning how to do 4-bar mechanisms, we were watching lots of different YouTubes on how to design 4-bar mechanisms. And we could do a lesson on that, but they may or may not be as good as what you find online. I think we should probably do that someday, Isaac. We'll want to make that as part of our official training. And then we could just share that out to the group, whatever video we end up creating. But there's some really, really great stuff out on YouTube for using FRC. And it mostly it's all about using the, kit of parts type of parts, or common off-the-shelf parts, COTS, into your diagram. Really common stuff. I mean, here we're putting a hex shaft through a bearing. Well, there's a feature script. So they're even talking about some of these scripts that you can use to make hex shafts really quick and easy and not have to design them from scratch, or make gussets or Swiss cheese your box, things like that. Really cool stuff. But that would be my advice, Jesse, is if you're just starting guarding, if you don't even know what the left mouse button and right mouse button do, start here. Start with the CAD basics. Go in here. They'll teach you how to do the basics of all of this stuff. What is a sketch versus what is an extrusion? Well, a sketch is the 2D version of the drawing, and then extrusion is taking that drawing and then giving it volume, extending it out. And then once you've extended that out, now you can do a sketch on a part of that to make a whole, or to even extend out in a different direction. One of the things that I think is different about CADing for either 3D printing or in this case building a robot compared to like if you were an architect, because my sister's an architect, is that architects 100% live sort of in a 2D world and everything comes off of a base sketch. But for us, when we're building things, we might sketch out a part and then extend it maybe up on the z-axis. And then on that part we just extruded, we may put a sketch on the side and then extrude out in the y-axis. And so we think more in an additive three-dimensional space, it seems, where we're just picking a face and saying, hey, there's a face of this thing. I'm going to put a sketch right here and then I'm going to extrude away from that. Where if you're maybe more of a classically trained type of architect, everything lives in a two-dimensional world and it comes up from there. It always goes up in the z-axis from there. And so I think that's something that's different about how things are different based on what it is what kind of industry you're in. I don't know if anyone has a different opinion on that. How do I stop sharing? There it is, stop sharing. But that's been sort of my experience. Anyone else have any questions or have any thoughts about OnShape or just CAD in general? Oh, Lexi, yeah, good comment. And I don't know if SketchUp, because it's an AutoCAD type of tool, and AutoCAD is a common thing for architects, if that's just sort of the nature of that, or if that's just sort of a limitation of the tool. But what does OnShape have for center of mass material analysis stuff? I do not know the answer to that. Does anyone else know the answer to that? I know that, all that stuff in SolidWorks is there. And so if you want to do stress analysis and things like that, yeah, that might be a strong reason to go to SolidWorks. If you want to do that type of stress analysis, or identify center of mass. I honestly have no clue if that's even in OnShape. That would be a really good thing to Google or watch a YouTube video on. One of the things that we love about OnShape is that we can have 3 students in the document at once, and we can have one person working on it and everybody else watching it, because it works like a Google Doc. And the downside to using SolidWorks is you're tied to a PC, and then you got to push your designs up to GrabCAD, and then other people have to push the designs down, and then they got to make sure they're working on the most recent version. So the nice thing about OnShape is that when our students go to OnShape and they go to the kind of the gold standard document that Isaac's been maintaining, they always know that they're looking at the most up-to-date version, and they know that what they're looking at is the latest design. So there's a lot of good things to be said about SolidWorks, but I think for the speed at which we have to move and the skill level, the variety of skill levels that we have to support, OnShape seems to be the best option for our team. Ben built a big bespoke tool to help students figure out center of mass for climbing. Yeah, that sounds not fun. Anyone else have any questions? I mean, I feel bad because Isaac and I have been doing all the talking. I prefer to have more discussion in these types of Sunday night calls. All right, no more questions. Well, That's fine with me. I don't mind wrapping up a little early, but now I do need people to talk. What do we want to talk about after Memorial Day? Because we're not going to meet next week because that's Memorial Day. Do we want to keep having these calls, or is it time to take the summer off? Or what do you guys want to do? I don't have anything else on the list. I think we've done all the topics that have been suggested so far. Ian, what's your favorite topic? Come on, buddy, help me out.
I swear I had one going into today, and then my mind completely blanked on what I was thinking of recommending. But I did have something.
I did find some notes. So last week or 2 weeks ago, last week was Mother's Day. 2 weeks ago, we talked about team legacy and how you help your teams kind of understand the history of your team a little bit. I don't feel like that's a big enough topic for a whole weekly call. But the reason why this came up is because Lexi, who's on the call here, she won Dean's List for our team this year. And the students around me said, is that the second one, the second Dean's List winner we've had? And I said, no, we've had 5. And I think that's important that the students understand, that history of it's a little bit easy. If you're in a space where you're going to hang up your blue banners, it's a little bit easy for them to look at the blue banners and say, oh yeah, we've got a history of winning regionals or winning chairmans, or if you've got a trophy case and you can put your plaques in there for winning, the Industrial Design Award. I mean, that helps students kind of understand the legacy that they're trying to live up to. But there's so much more that it's just than just material stuff that I think is really great to try to instill. And I'm looking for advice or ways that other teams are sort of helping educate new students on the legacy of the team, and of course sort of establishing the team pride that the veterans on the team have into the younger students to kind of get that going much earlier and get them understanding they're part of something bigger than them just being on a team for the first year. But I don't know that's not a full team topic or a full Sunday night topic. I'm curious if there are folks out there running FLL and other FTC teams. I'd love to hear how they're doing that. We're having some discussions within Nightcrawler. We have attempted to support FTC teams in the past. It's been a struggle. We're considering trying to do something with FLL, but we don't know anything about it. So I'd be open to that, but it's not a discussion that I can even contribute to because we don't know much about it.
Yeah, that would be a really cool discussion because I know 3926 is trying to start an FTC team with our middle school and then an FLL team with the Tony Sana Foundation, which we've been partnering with, which is a recreational facility for underrepresented and underprivileged students. We've been working with them with their Lego robots already. And so we're a little daunted by them asking us to start an FLL team. We really want to. And so having advice on, what's needed to do that or, and to do an FTC team as well would be very helpful.
Is there anyone on the call tonight that I know that we've had people on the call before that run multiple FTC and FLL teams, and King Tech is one of those that runs 2 or 3 or 4 FTC teams in parallel with their FRC. I've talked to their mentors about that before. I know that we've got other teams that run multiple FLL tournaments. 3291. Who's 3291, Tanya? Tanya.
Golden Pirates.
Golden Pirates. Oh, excellent.
And this is the first time I've jumped on the call. So thanks for sending out the invites and some wanted to jump in. But we run 4 FTC teams in the fall that we invite our middle school feeder schools to. So we run a middle school, high school. We do not do FLL. And we kind of run the same model as 2526 Maple Grove. They also run 4 FTC teams.
Wow. Okay, so I feel like we might have something here, but we need to make sure those folks are on the call next week. Or 2 weeks, Tanya, and whoever else we can get to jump in here. Do we feel like we can pull that off? We can get people here to talk about running FLL and FTC? mean, I think
I can talk FTC. I can't talk FLL.
okay. Maybe we should do that. Maybe we should put the word out. I'm going to look for everybody here to help with that, to put the word out. I will send out the email reminder of the meeting coming up. Maybe what I'll do is I'll send out, because we're not going to meet next Sunday because it's Memorial Day. I'll send out an email saying, hey, no meeting because it's Memorial Day. And then I'll ask, we would like to hear from teams that are running FLL and FTC. And hopefully the next Sunday we'll show up and there'll be people there that can talk about it. And if not, we'll just sit and talk about the picnics that we had on Memorial Day weekend, all the fish we caught.
That is a timely topic for us at 7028th Binary Battalion, because we are looking to get our FTC team up and running for next fall. We're in the very early stages of trying to figure out, first of all, registration and getting the volunteers and mentors and such, and what kind of structure do you have for coaches versus mentors, and we have had an FTC team in the past, but they were housed at the middle school and also right after school. And so some of the feedback that we got was mentors were hard to come by because they couldn't get off work in time. So we're going to attempt this time. We're going to have it at the high school, and it'll run concurrently with our preseason FRC team. And the high school kids will be mentors, kind of modeled after Becker's system, which is pretty good.
So I'll share a little bit of a preview of what I can contribute next week. We've tried FTC a couple of different ways. So we tried to do FTC as a JV team. The first 2 years I was part of the team, so that would have been 7 years ago and 8 years ago. And what we found is that our mentors spent so much time in the fall with FTC kids trying to get them a competitive robot that we failed to do FRC training. And then when it came to be January, we had too many kids who had forgotten how to do things in FRC or had never been trained in FRC, and it really hurt our FRC robot. So we ended up abandoning the idea of using FTC as a JV team because we just didn't have the mentor kind of support to be able to run two teams that way. Then Nate, who's our lead build mentor and was the founder of the team 17 years ago, he was working at the middle school. He now works at the other high school in our district, but he was working at the middle school as their IT tech person. And so he volunteered to help run the FTC team at the middle school when a teacher who had been running it left, and he took it over. But then it was after school. Luckily for him, I run my own company and I can work whenever I want. So I would go over there and help him with the programming part of that. But again, it just became a lot to try to get mentors there after school. It was just the two of us, which is fine. Two mentors for an FTC team isn't too bad. But it was us after school at middle school and then almost immediately to the high school. And it was just a lot for adults to try to do all of them again. So we're thinking about trying to do it in the evening in parallel with the high school team, the FRC team, but then it creates an equity problem. The reason why it was after school at the middle school is because there was an activity bus and kids could stay after school for an activity and they could get the bus home. And now you've created a program where the only kids that can attend are parents who don't have to work nights, or there's two parents at home and one can take a kid to robots and the other one can take care of the other children. So we have a big equity initiative on Nightcrawler, and we try not to do things that create equity problems. So we're sort of in this weird spot where we're looking for advice on how to do things because we don't feel like we've done a good job of running FTC successfully. We're looking for help and advice.
Okay, I did remember the one I was going to ask about was going to be finding mentors for teams. But then what you just said reminded me of another potential meeting topic we could talk about. Equity initiatives on teams, because I know 3926 has been doing their equity initiative and 2052 has one. And it would be interesting just to hear from all of the teams that have been doing those, what they've been trying to do to make their teams more equitable for all students.
I have a feeling that'll probably end up being a big topic of discussion when we talk about FLL and FTC. So I am super happy to combine those two things. I don't know that FLL and FTC would take the whole night anyway. So all in favor of combining those two topics, because personally, I think those two things are very, very much conjoined. Great. Thank you. And if it turns out that the equity discussion gets way bigger than what we can accomplish while trying to talk about FLL and FTC, there's no reason why we can't have another meeting to talk about that as well. All right. Well, great. This went so much better that I was worried that we were going to run out of things to talk about. We're going to be done super early, or we'd end up only getting to like half of what we wanted. This all worked out perfect. Great job, Isaac. I know it was really fast for everybody, but the goal tonight, and I told Isaac this too, and I probably should have started the meeting with this. The goal wasn't to teach everybody how to do OnShape. There's people that'll do better training than we can do on a 60-minute call here tonight. The goal was to kind of show how quick and easy it is to do things in OnShape once you've learned the basics. And so hopefully we've accomplished that tonight. And now you're inspired to go out and do that OnShape training and learn the basics. And honestly, I really hope they fix that MKCAD bug before the end of the summer, because it's a super helpful tool. You can always go out and find the parts and import them yourself, but that MKCAD tool is so nifty for just pulling in parts real quick and getting them into your assemblies. All right. Well, thank you, everybody. I know that I had a smaller crowd, and it'll probably be a smaller crowd through the whole summer, but we get a lot of YouTube watches, so I'm confident this will be a well-watched video. So once again, thank you. I will send out a meeting reminder that we're not meeting next week, but ask for FLL and FTC help, and then we'll meet the Sunday after Memorial Day. All right. And if you know people, like you guys have a lot of people here have said they know teams that are running FLL or FTC or both. So please invite them to our call. And then at the bottom of every email I send out for a reminder of the meeting is the link to sign up for the form. So send that off to your friends and say, hey, sign up for this form so you don't forget about our meeting, so you can come tell us all about your FTC and FLL success. All right. Have a good night, everyone. Thank you.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.